Okay, so today we're going to look at drawing Lewis dot structures. It's really easy to do if you have a periodic table. Um, you can tell what number of valence electrons an element has by numbering them across. You can see I've numbered my periodic table here. And valence electrons are the outermost electrons an element has. Those are the ones that are used in bonding. So you see I've numbered mine that group 1 has one valence electron, and everything in group 1 has one valence electron. Everything in group 2 has 2. All the transition metals have 2. Group 13 has 3. The carbon group has 4. Nitrogen has 5. Oxygen has 5. Or oxygen has 6. Fluorine has 7. And the noble gases have 8. Okay, so the goal of bonding is so that you're happy and stable. If you have a full valence shell, remember valence are the outermost electrons. If you have a full valence shell, you're happy and stable. So everything is trying to achieve this full valence shell of 8. So that's an important number. So make sure you've labeled your periodic table counting across 1 through 8. That'll be important. And again, everything below these elements also has the same number of valence electrons as the element above it. The periodic table is a weird shape, but it kind of works out nicely this way. So what we're going to do is use that and have your molecular model kit handy. Okay, so once you draw, or if you're having trouble drawing your Lewis dot structures, you can use your model kit to kind of see the model in 3D space so that you can work out maybe what the drawing should look like according to your 3D model. Okay. So when we fill in valence electrons, we fill them in clockwise. So here we have element X. And it's just the order of filling electrons. Element X is not a real element. I'm just showing the order that they go in. And we're going to fill them in clockwise again. So element X gets its first valence electron here, its second, its third, its fourth, its fifth, its sixth, its seventh, and its eighth valence electron. Okay, so now it has a full valence shell. Okay, but they just go in that order when you fill them. Okay. All right, so hydrogen has one valence electron. We've drawn its dot right here. Okay. Beryllium has two valence electrons, so we go clockwise. 1, 2. They're separate. Boron has 3. 1, 2, 3. When we get to carbon, carbon has 4. They're still going to go clockwise. Okay. So we're going to go 1, 2, 3, 4. Hydrogen has 4 dots, 4 open valence electrons. It can make 4 bonds. Nitrogen has 5. So I'm going to draw the first 4 just like carbon. Okay. So there's our nitrogen with 4. We're going to draw the 5th one on top, continuing our clockwise pattern. Okay. And when I hold up this nitrogen, the nitrogen has 5 valence electrons. It has 3 open valence electrons because the pair on the top is bonded and cannot form a bond. Okay, so paired electrons cannot bond. Oxygen has 6. 1, 2, 3, 4, 5, 6. Oxygen can bond twice because it has 2 open electrons on the side and on the bottom. Again, the paired electrons cannot bond. Fluorine has 7. 1, 2, 3, 4, 5, 6, 7. Again, I'm drawing them clockwise. Fluorine can bond 1 time. When we get to helium, helium has a valence shell of 2 because it has 2 electrons total. Sorry, this is helium. Okay, so 2 electrons total for helium, and they are bonded. And by bonded, I mean they're paired. So we're going to draw 1, 2. Doesn't matter which side you draw them, but they are both paired together. I've drawn them paired on the top. Neon has 8 valence electrons, so all of its sides are going to be full. So 1, 2, 3, 4, 5, 6, 7, and 8. So there is a full neon, and these are the full drawings of Lewis dot structures for 1 through 7 valence electrons and what they look like. Okay, for the next step, you want to have your molecular modeling kit handy. Okay, and these are the colors of my molecular modeling kit. Most of the molecular modeling kits are the same. Everyone I've seen have the same colors, but these are the colors of each group. And remember, groups go up and down. Okay, so if you have a hydrogen, you're going to use a white ball. It has one socket because it can form one bond. Let's see, black is a carbon. It has 4 sockets. It can form 4 bonds. And this is the carbon group. So it's group 14 right here. So any black sphere that you use could be any element in the carbon group, like carbon, silicon, germanium, okay? Let's continue with our colors. We have red. Red is the oxygen group. It has 2 sockets because it can form 2 bonds. Let's see, green. Green is a halogen. Halogens are in that group 17, so fluorine, chlorine, bromine, iodine, things like that. And our last one is blue. Blue can be either the boron group or the nitrogen group. They can both bond 3 times. This has 3 open sockets. Okay, so make sure you've noted those colors down. Your teacher can write them on the board for you if need be to remind you. But the groups are listed here of which color is which element, and the ones below it are the same color and have the same number of valence electrons and can form the same number of bonds. Okay, so let's take an element, or a compound actually. Let's take H2O. Okay, if you look at H2O, it contains hydrogen and oxygen. Okay, now hydrogen has 1 valence electron. It has 1 dot. So we've drawn that 1 dot on the top. Oxygen has 6 valence electrons, so we fill them in. 1, 2, 3, 4, 5, and 6. Okay. I have trouble going clockwise because I'm reversed on the computer. However, so it has 6. It can bond 2 times, which is why there are 2 hydrogens that bond to this 1 oxygen. So what we can show is we'll move our hydrogens so they're next to the electrons that can bond on the oxygen. Notice hydrogen had its valence electron up here. Okay, we've moved it to the side so that it's pointing at the electron in the oxygen that can bond, okay, because covalent bonds are sharing electrons. So what we'll do to show that we have a covalent bond is we'll circle those 2 electrons. So we've circled 1 covalent bond, and now we'll circle our second covalent bond, okay. Now, if you look, happy and stable is 8 valence electrons. Our oxygen has 1, 2, 3, 4, 5, 6 valence electrons to begin with. It's sharing 1 electron with hydrogen here and 1 electron with this hydrogen here. So this oxygen thinks it has 8 valence electrons with the extra 2 from the 2 hydrogens. The hydrogens think it has 2 valence electrons, which is great, because a full valence shell for hydrogen is 2 because the noble gas to the side of hydrogen is helium. Helium is full at 2 valence electrons. So our Lewis dot structure is good and it's correct because all our elements are happy and stable. And then if we build it, red is oxygen, 2 sockets, and we need 2 hydrogens, and we're going to use are single bonds. These are single bonds, and these bendy ones are double bonds, but oxygen and hydrogen form single bonds to make water, and this is our water. So we can hold it up to our drawing, and we can see that we have our oxygen in the middle, and our hydrogens are bonded on the outside, just like in our 3D model. Okay, so we can do this with other elements. So we have NH3, Okay, we have a nitrogen and a hydrogen. Okay, hopefully you remember that hydrogen has one dot. Do you remember how many dots nitrogen has? Hopefully you're looking at your periodic table and saying 5. So you'll draw in your dots. Hydrogen has one dot. Nitrogen has 1, 2, 3, 4, 5. Okay, so here's our hydrogen and our nitrogen. Hydrogen can bond once, and our nitrogen can bond 3 times. 1, 2, 3. These valence electrons are paired, they cannot bond. Okay, so what we'll do is we'll separate. So we have our nitrogen in the middle and our hydrogens on the outside where they can bond. And I'm going to draw on my one dot on my hydrogens. And they're going to be pointed toward the nitrogen where they can bond. We're going to circle the 3. 1, 2, 3. So here we have NH3. Okay, there's not a bond on the top because those two are already paired. These guys bond here, these guys bond here, and these guys bond here. So the nitrogen already has 5 valence electrons. It needs 3 more to get to 8. It bonds with this one, and this one. And 5 plus 3 is 8. The nitrogen thinks it has 3 valence electrons. Or, sorry, plus 3 valence electrons. 5 plus 3 is 8. Okay, and here is our NH3. Okay, N is in the middle because it can form 3 bonds. Something with 1 bond would not be in the middle because it can only bond 1 time. And the hydrogens are on the outside. If you would like, there's these little paddle things that you can stick on the top of your nitrogens to show that they have it's called a lone pair of electrons. It's a lone and it is not bonded, so it's a lone pair, a little paddle, and that can be shown on the top. Okay. So we want to make sure we know what double bonds do. So oxygen gas, very important if you like breathing, will form a double bond. Oxygen, if you look at your periodic table, okay, it has 6 valence electrons. We're going to draw 6 dots. Okay. So 1, 2, 3, 4, 5, 6. You'll draw your oxygen like this. It can form 2 bonds. Okay, so I've drawn 2 oxygen next to each other. I'm going to draw one exactly like this, and I'm going to draw the other one as a mirror image of that oxygen so that they can bond together. Okay, so 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So our oxygens each have 6 valence electrons. They're a mirror image. I put them pointing toward each other so that I could easily circle the bonds. If I had both oxygens looking like this, I would be trying to circle out from around this side and it'd be slightly awkward. It would work, but it's just not as pretty. So I'm going to circle the middle and the bottom. So circling the middle and circling the bottom. Okay, so there's a double bond because we have 2 shared pairs of electrons. And here's where your bendy bonds come in. Okay, so this is an oxygen. It can form 2 bonds, and I'll break it apart so you can see. It's slightly awkward when building them, but what you do is you put one together. There's still 2 open sockets, so you need to fill all your sockets in order for your molecule to be correct. And we push and fill it in, make it nice and pretty, and we don't have any open sockets, so we know we are done. Okay, so your Lewis dot structures are really easy to draw. If you have your periodic table, you'll get a chance to try some now. Make sure you just constantly check back in your periodic table and check how many valence electrons each element has, and then fill in your elements clockwise so you can draw them, and then build them to make sure that you've done them correctly and you can see how they look in 3D space. Good luck.